So today's lesson is it's called adding and subtracting day 2, but it's essentially adding, subtracting, multiplying, and dividing day 2. It's kind of like the day 2 of the last 2 days, okay? And what's happening is that we're gonna be working with complex fractions, okay? Complex fractions mean you have a fraction divided by another fraction, okay? Yes. So what this number 1 says, and you can see in your instructions, it says assume all expressions are defined. What does that mean? We don't have to do that. Good. You don't have to do that. X doesn't equal. So number 1 says 1/3 divided by 3 over x. Okay? So what we want to do is think about this as 1/3 divided by 3 over x. Well, how do we divide fractions? Okay, keep the first, change division to multiplication, and flip the second. So what do we end up with? Okay? The idea is that you've got to be able to envision what's being divided by what, so that then you can deal with it. Okay? Look at number 2. X plus 1 over x squared minus 1 over x over x minus 1. So again, envision what's being divided by what. Okay? Rewrite it out if you want. You're not going to have to do this step every time, but just while you're practicing kind of seeing it. From here, what do we do? Okay, so keep your first fraction. Change division to multiplication. And flip your second fraction. Now, these 2 fractions are being multiplied, correct? When we multiply rationals, our goal is always to get everything as factored as possible so we can cancel stuff out. Do you see anything here that can be factored? Good. So my x plus 1 is a factor on top. X squared minus 1 becomes x plus 1 times x minus 1 times x minus 1 over x. Once you have everything in terms of your factors, you're allowed to cancel. But what are you only allowed to cancel? Factors. So do we have any factors that we can cancel?
X plus 1 and x minus 1.
Good. What do we end up with?
1 over x.
Okay? Yeah.
So if your instructions say assume all are defined, even if like this, where we know x can equal 0, you just ignore that?
So when it says assume your expressions are defined, that means that they've already taken into account which ones it wouldn't be defined for. So you don't have to list that. Okay? So you can basically say, the instructions could say in a different way, simplify this where x does not equal 0 plus or minus 1. And then you just don't come up with your answer. Yeah?
Would you get points off like on a quiz or test, like if you define them?
No. I just don't want you to waste your time. Yeah?
When you solve these, is x is not equal to 0, is that like assumed whenever you're doing this? Because there are a lot of times I noticed that like 0 couldn't have been x, but we didn't write it down.
That's not true. Anytime we were identifying x values that were undefined, if x can't equal 0, it's written down. Okay? All right, 3 over x plus x over 2 divided by x minus 1 over x. Okay. In numbers 1 and 2, we had a single fraction divided by a single other fraction. Okay? Here we've got 2 fractions being added in our numerator. So our first task is to simplify our numerator to get it to be just 1 fraction. Okay? So we have to add 3 plus x, or 3 over x, plus x plus 2. And in order to add those fractions, what do we need to do? A common denominator. What would our common denominator be in this case? 2x. So this is 3 over x plus x over 2. What am I going to multiply my denominator of x by? 2 over 2. And what about 2? X. Whatever you do on bottom, do the top. So that gives us 6 over 2x plus x squared over 2x, which gives us what?
6 plus x squared over 2x.
Any questions on simplifying that numerator?
And you can't simplify this anymore, right?
This numerator?
Yeah.
No. 6 plus x squared over 2x is fully simplified. Okay. Are we going to need to simplify the denominator at all?
No.
No, it's already in one single fraction. Okay? So I'm just going to kind of rewrite it down here. Now you remember that these two are being divided. So we keep the first fraction. Change our division to multiplication. And flip our second fraction. Once you start multiplying, I think it's important to add in your parentheses around your factors. So that you remember that that x minus 1 is connected. It's attached to each other. They cannot be broken up. Does anything else factor in here? No. The only other thing that might is this 6x squared, right? But it doesn't. All right? Can we simplify anything? Does anything cancel? X over 2x, yeah. Or sorry, just x over x. We know those cancel. So what are we left with?
6 plus x squared over 2x.
Good. I'm going to go ahead and write it as x squared plus 6 just because that's a little bit more quote-unquote proper.
Could we not simplify the x squared plus 6?
What? There's no way that x squared plus 6 simplifies. If it did factor, yeah, you could factor and see if anything canceled. Other questions on this one? Okay. Go ahead and copy this one down. Okay, on this one, we're going to have to simplify both the numerator and the denominator. Okay? So at first, I want you to pretty much think of it as two separate problems. Deal with the numerator, deal with the denominator, and only then are you going to even think about actually dividing. Okay? So, what would our LCD for our numerator be? Anyone have trouble seeing that? Okay. We've got y squared in one denominator, which means the factor of y happens twice in a single denominator. When it happens twice in one denominator, it's got to happen twice in your common denominator. Okay? Okay. So I have 1 over xy minus 1 over y squared. What do I need to multiply xy by? Y. And what do I need to multiply y squared by? So that gets me y over xy squared minus x over xy squared, which finally just gives me y minus x over xy squared. Any questions on that step? Okay. Now, we're going to simplify the denominator. What LCD do we want to use for the denominator? Great. X squared, y squared. What do we multiply this first one by?
Y.
And what about the second one? So we get x over x squared, y squared, minus, or sorry, that y should be on top. Minus x over x squared, y squared, which gives me what? Great. And now it's important to remember that's what's happening between these two fractions.
Is it?
Oh, sorry, I did that in the last class too. I don't know. I got nothing.
Sorry, I just thought maybe.
All right, so these fractions are being divided. So keep your numerator. Divided by changes to what?
Multiplied by.
Multiply. And then we flip our denominator.
So it's x squared y squared over y.
All right, add in parentheses on any factors that need to be grouped together.
Cross out.
What can you cross off?
Y squared.
Y squared, I agree. And,
X squared.
yeah, x squared over x. Dun, 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 dun. So cool! It starts with this like intense looking problem, and then at the end it's just tied up in this neat little bow for us.
That doesn't make us happy.
It makes me so happy.
Why would anyone buy that?
Okay,
Probably would have guessed like X.
let's look at number 5.
Mine is
3 over x minus 4 divided by 1 minus 2 over x minus 4. Okay, do we need to simplify the numerator at all?
No.
Okay, what about the denominator?
No.
Yes. Picture 1 as 1 over 1, right? So what's our LCD going to be? Yeah. So I would have to multiply that 1 by x minus 4 over x minus 4. Do I have to multiply 2 over x minus 4 by anything? No. So we get x minus 4 over x minus 4 minus 2 over x minus 4,
Why?
which gives us x minus 6 over x minus 4. Why can't what? Okay. Any other questions on that part?
Wouldn't it be 2x?
No, because it's x minus 4 minus 2.
2 doesn't.
You sure?
Yeah.
Okay. What happens with your numerator? Okay, you stay the same. So this is 3 over x minus 4. All right, so keep, change, and then flip.
Wait, so can you only cross off, like, so you can cross off the x minus 4, but can you only do that because it's, like, diagonal, or could you do that if x minus
4 was on top of that.
Yeah.
The reason you can cancel the x minus 4's here is because they are both factors. And when things are factors, as long as everything's being multiplied, you can rearrange them however you want to picture them. So yes, if this x minus 4 ended up over here, as long as it was still a factor, you could cancel there.
So like if x minus 6, say like x minus 6 and x minus 4 like flipped, you would just have to keep x minus 4 though because it was both of them.
Yes.
Okay.
X minus 4 is... Hang on one second, I'll show you. Okay, so here's our answer to this one. Are there any questions on this one?
Could you not simplify the 3 and the 6?
No, because what are you only allowed to simplify? Factors, and x minus 6 is a factor. Okay, so the question arose as what would happen if you had 1 over x minus 4 times x plus 1 over x minus 4. Anya, is this what you were talking about?
Yeah.
And this is what you were curious about? Okay, so in this case, nothing cancels. This would end up, you multiply across the top, x plus 1 over x minus 4 times x minus 4. Or x minus 4 squared. But they can't cancel because you're not dividing one by the other to make it become 1. Okay? Okay, let's look at number 6.
I could look at it. Just think that over. Just say everything in minus 4.
You can't write it like all
Okay. Guys, I need you to kind of quiet down, please.
No.
Okay. I'm going to wait. Okay. What does the power of negative 1 mean?
1 over.
1 over that. Okay? So, this is going to become, what is x to the negative 1?
1 over x.
What is y to the negative 1? Okay? What? And then x to the negative 1 is 1 over x minus now 1 over y. These negative 1s are not being applied to the whole numerator. Just x and then just y. So you have to deal with them separately.
If it was, could you put them like if there was parentheses like x?
If the situation was x plus y to the negative 1, yes, you could move all of that to the denominator. But you've got to remember that this is not equivalent to this. Okay? You're moving it to the denominator of this single fraction. You can't move it to the denominator of this big, complex fraction. Okay? All right, so now this problem is just like number 5. You need to find an LCD for your numerator and an LCD for your denominator. What's your LCD going to be for your numerator? Okay. Take a sec and please simplify your numerator. Did you get y plus x over xy for your numerator? Yes. All right. Any questions about that? You okay, Ashton?
Yes.
Okay. Now let's simplify your denominator. What's our LCD for our denominator? xy. So then we're going to multiply by y over y, by x over x. We're going to get y minus x over xy. Okay? Now, these two fractions are being divided. So you keep your first fraction, change division to multiplication, and flip your second fraction. Okay, I would add in parentheses around any of your factors that are being added or subtracted because you want to make sure you force yourself to remember that those are attached. Okay, can anything cancel? Good, and what are we left with? Okay, now some of y'all might be looking at this thinking this has to simplify further. Okay, it in fact does not. Okay, the idea is, you remember how we tried to manipulate things by pulling out like a -1? Okay, in this case, in the top, both the x and the y are positive. And in the denominator, they have opposite signs. So if you pull out a negative, the signs are going to stay the same on top and still be opposite on the bottom. So you're never going to make them match up. But if you're not sure, just try and play around with it and double check. Okay, but that is your final answer here. Questions about that? Okay. Go ahead and copy down number 8, please.
Where's the middle line?
It's 1 over x plus 2 plus 1 over x minus 5 divided by, here's your division sign.
Guys, we don't need commentary.
Okay, so what are we going to have to do first? Good. In the numerator, we're going to need to combine those fractions. What should we use as our LCD? Okay. So I have 1 over x plus 2 plus 1 over x minus 5. What am I going to multiply this first one by? And then the second one by x plus 2. So we're going to end up with x minus 5 over our LCD plus x minus 2. And when we simplify that, what are we going to get?
X minus 5. Like you're combining, okay. I just wouldn't know yet.
2x minus 3 over x minus 5 times x plus 3. Questions on that step? Yes, sorry. X minus 5 times x plus 2. Okay, look at your bottom fraction. Okay? Notice that your bottom fraction is already one single fraction, right? So it's okay to go ahead and do keep, change, flip here. I think it's easier to do that than to factor here. I think we should wait and factor in just a minute. But if you really, really want to factor first, you can. But I'm going to go ahead and just kind of carry this guy on down. Because my goal with these fractions is to get two single fractions. One fraction divided by another fraction. All right, so I'm going to keep change division to multiplication, and flip. Everyone okay so far? Now that this is a multiplication problem, we do want to get everything as factored as possible to make sure.
Will you put some here and I'll text her, but if she would just have a kid pass these out and put the keys up and they all know.
Okay. Yeah. Now, since we're multiplying these fractions now, we've gotten it to where we're multiplying, we've got to get everything as factored as possible so that we can hopefully cross some stuff off. Okay? So how does anything else factor here? No. So I'm going to go ahead and just rewrite this. Okay? What about my numerator here? X squared minus 3x minus 10. Good. Divided by, okay, look at 2x squared minus x minus 3. Can we use the shortcut there? No, why not? Good, there's a 2 right here. So we got to think. 2 times negative 3 is negative 6. What are factors of negative 6 that add up to negative 1? Positive 2, negative 3. Okay, so we've got 2x squared minus 3x plus x minus 3. No, sorry, plus 2x minus 3. All right, group. We pull out an x, we've got 2x minus 3. Pull out a 1, we've got 2x minus 3. So would you agree that this factors into x plus 1 times 2x minus 3? Yeah? All right, what do we get to do? Cancel. What cancels?
X minus 5, x plus 2.
Boom, boom, boom. What do we get?
1 over x plus 1.
Awesome.
Yeah. That was so cool.
Wait,
Look
from
how small the package is
complex fraction to simple.
They're mocking me, aren't they?
Yeah.
Yeah.
Such a rush.
I almost died.
Okay. Reminder about your quiz tomorrow. Okay? Your quiz tomorrow covers 7.1 through 7.4. Please remember that 7.1 was variation, okay? Direct variation, inverse variation, combined variation, and joint variation. Okay, so don't forget about that. Then there's adding and subtracting, multiplying, dividing, and then complex fractions. Okay?
So everything in complex is fine?
Yeah, everything so far. It will be non-calculator, but I assure you that the variation ones are numbers that you can multiply and divide in your head. 10 over 20. Okay? 10 times 5. You can do these things. Okay? Okay, any questions about your quiz? Any questions about your quiz? Okay. Your homework tonight. Your homework tonight. You make omit numbers 13 through 15 and number 54. 13 through 15 and number 54.